The third topic I want to talk about is data. Data is so critically important.
Chris, we're the presenter view.
Oh, yes, I'm sorry. I'm sharing screen. Oh, okay. I got the wrong. Oh, I see what's happening. When I jumped back in, I shared the wrong window. Is that better?
Yep.
Okay, thank you. So data plays two very fundamental roles. One, it's how you may train a model. If you're actually training a model, if that's part of your AI strategy. But even if you're not training any model, even if you're using pre-existing models, data may be the target of your analytics, that you're building a model which analyzes data, and it's your customer data or general market data that's available in your vertical segment that becomes the key to your value proposition. And so there's a close correlation between how well you master data and how well you master markets. And I thought the other day about where does the data come from? And I think fundamentally, you've got 5 strategies with respect to data. Number 1, you're going to use the customer's data. This is relatively easy to do in the consumer space. I mean, the social media companies do this all the time. They harvest incredible amounts of value, often in the form of creating an advertising platform that extracts a little bit of information about you and turns that into a value proposition to advertisers. And the users in this case are willing to tolerate the loss of their data because they're getting something in return. But it's tough to find an area where customers are going to freely give up their data in return for something you're giving away, because the social media giants are really in such a strong position to leverage that data and can offer something in terms of other data services in return effectively for that release. You use Google because they're, giving you Google Maps and YouTube and other things that you enjoy. So you're getting something for free and you're tolerating the advertising. And it works, of course, better in consumer. Most enterprises are not going to allow unrestricted use of the data that flows through their system. Now, you may be able to develop a system in which you isolate the data of each customer, that you provide strong security that says that this data is only being used for the benefit of this customer. It's not going back in to training a general purpose model. It's not going back in to the benefit for the application as a whole. It really is a service on the customer's data. And you may be able to use that for very specialized training, like fine-tuning on a per customer basis. Each customer's data may be kind of different, so it has almost inevitably a pretty strong services component. So that's data type number 2. It's still customer data, but it's isolated lakes of data. The third area is there's an enormous amount of public data out there, freely available streams on different topics. Data.gov, for example, hosts 300,000 data sets on all kinds of things: economic data, agriculture data, almost anything that the government collects as data is available in some form in these data sets, sometimes anonymized, of course. Plus, there are public markets. You think about real estate transactions and stock prices and so forth. Lots of really interesting economic data, often very fine-grained. The universities build data sets, sometimes not very large data sets. The major cloud players try to be good citizens. There are potential challenges of differentiation, but you can think of lots of ways that you might be able to build a practice, build a tool which has, at least as part of it, the interpretation of, say, government data into a form which is useful in that community. If you have a novel way of processing weather data or geosatellite data or agriculture crop data into something which helps in the markets, that can be killer. You may develop unique private data sources, especially if getting that data is a key element of strategy and it's a part of the overall system. So, for example, you may have a new kind of sensor and you may build a new kind of satellite that gives you a new kind of Earth imaging data. You may also be able to do exclusive purchase and repurposing of proprietary data streams, but where that data stream is central to the value proposition. And then finally, you can just implicitly use data. You don't actually gather any data of your own. And you just count on OpenAI and Anthropic and Google collecting that data. Because after all, they are training on tens of trillions of bytes of scraped data. And you use those models as is, but you focus on novel sweet spots in that data utility. And the software code tools are clearly part of it. There's a challenge of differentiation because you're using the same models as everybody else. And so the data that you're relying on is essentially commoditized. But I think of those as the 5 data strategies. I think there's one basic idea that's so important that it's worth reinforcing. This is something that all of you already understand, but I'm going to say it again. That fundamentally AI is mapping an input distribution to an output distribution. And so the question arises around what does a model do with input data which is outside of its training distribution? And the honest answer is you have no idea. You may have a human notion of what would be the reasonable behavior of this model in the presence of some new data that's not similar to what it's seen before, but there's no reason to expect that your model is going to behave in a human reasonable fashion. And so you have to really figure out what is the distribution of your input data. How are customers actually using it? And as you move to new customers, does it imply new distribution of data, some of which your model may never have seen before? Of course, it implies that one of the things you need to do is have more diverse training data so that you have a better sweet spot, so that as you expand into new use cases, that you're not moving outside of your distribution. It also says that even if you are still only gathering training data across a specific distribution, you should really try hard to gather testing data across a broader distribution than you gather training data, on the assumption that you don't need as much testing data as you need training data, and that broader testing data can be the canary in the coal mine that tells you when your real use is, or rather, it tells you when your model is going to be really misbehaving if it were to see out of distribution data. And so you know where your vulnerabilities are, in which parts of the input distribution, in which parts of the distribution that you don't yet cover, should you be most scared. And by having this broader testing distribution, you will stay one step ahead. In addition, you should always ask the question when you take on a new customer or a new class of customers, what's different about their data? And do I need to change my training in order to cover them? And really, as a piece of engineering advice, I recommend an obsession on quality, safety, and compliance. You really can get into a lot of trouble as you scale if you don't have a handle on measuring what your AI system is really doing. That by getting a handle on your data distributions, understanding the data distributions of your customers, understanding what you do and do not do well on in your model, you do extra work, but it pays off in supportability. So by investing in broad representative test data first, and then you worry second about training data, you stay ahead of the surprises. And there's lots of ways of augmenting your subsystem and end-to-end testing and synthetic data generation and using models to judge models and crowdsourcing human opinions and negotiating with customers for test data, adding customers' bad cases to your test suite may be a win-win, but really get a lot of obsession about testing. AI safety is something people talk about a lot, and I'm not sure how much they do about it. I think an attitude of paranoia is really important because it's rare events that will get you in trouble. I think you also have to be aware of what happens as we compose complex AI models into even larger complex systems. That you may have a set of systems which are each 99% correct. That they're almost always right. I love how robust this individual system is. But then I chain 10 of them together. And even if they're uncorrelated, I get a really big problem that 10 systems in series with uncorrelated error has really miserable robustness. We often count on having the human in the loop to help us become aware of these rare events when the model goes off the rail and starts spouting, Nazi propaganda. Yes, it's very rare, but if you catch it soon, maybe you can tolerate it. But the humans have to be paying attention. And we're also moving in the direction of having truly autonomous systems where the human is just barely in the loop. They may be in the output, but the system can go off the rails a long way before the human wakes up and says, you find out that your system isn't behaving badly when there's a front page article in the New York Times. That's not the human you want in the loop. And so you have to look all the time at the risk of something going wrong and the consequentiality of that going wrong. And there's certainly going to be some high consequence areas that require extra attention. Autonomous vehicles and robotics, healthcare, law enforcement and defense, financial transactions, public media, cybersecurity. These are all things that if they go a little bit wrong, they can put you out of business overnight. And there's lots of issues of compliance that we have to pay attention to. Of course, customers don't really understand how your product fits into the requirements in their jurisdictions. They are not going to be able to evaluate your product. So you need to be able to make some fairly sweeping statements so that they are reassured on their jurisdictional compliance. They do not want to dig inside your technology to figure out if they can use it in the EU. They're going to ask you, does this comply with EU law? So they're relying on you to make sure that they comply with the law. So there are many dimensions of compliance, and typically that includes fairness in consequential decisions, protection of personal data privacy, and appropriate jurisdictional residency, like this data can't leave the EU. There's especially strict controls on biometric information and surveillance. Customers should get transparency and accountability. If something goes wrong, they want to know exactly how it went wrong and who they talk to find out about it. They want to know that there is some human oversight so things don't go off the rails. There's lots of concerns about copywriting of training data, and they don't want to be caught up in the copyright fights. They want to understand where the risks are, and they want to understand sustainability. What's the environmental impact of this? And especially given that as we scale the absolute amount of computing that we're doing, the energy impact and the environmental impact of AI is a really growing concern. So these are things that you have to take seriously, particularly if you're a leader, particularly if you're understanding that the customers may be more naive and more diverse than you imagined at the outset. So to wrap it all up, there is, I think, a kind of success formula here that you can put together as you're choosing AI. Choose an area of deep interest, expertise, and backstory. I think there's also an argument that on average, there's more white space in vertical markets than horizontal. That isn't absolutely the case, and it may be that your expertise and interest favor a deep AI investment over a vertical story. I mean, if you know nothing about real estate and don't actually care about real estate, don't go into real estate products. Start building relationships, problem understanding, and understand the market dynamics in that area, especially in that vertical. Go talk to 100 people. Don't say, well, I talked to my cousin and I talked to a friend of a friend who are both in real estate. You got to talk to more people and understand their fear and their greed. What are they hoping for? What are they afraid of as they build their business, as they adopt technologies? Systematically investigate large data sources in the domain. Figure out where can you leverage the ability for large AI models to handle vast amounts of data in a way that humans and generally existing software systems never could. Brainstorm lots of different value propositions. Understand where you can go deeper in an operational analysis of your customers' data, or automate currently manual workflows, or where can you look at the compliance and audit and security issues. Look for the problems created by AI proliferation. You may be the case that the answer for you is that you harness and limit some other piece of AI that's gotten into the system. You make it useful. And start building user experience prototypes. Figure out what the algorithms can do. Cobble together things. Use all these great AI coding tools to build prototypes in days or a few weeks that you can use as conversation starters. Develop 2 talk tracks. And this is true across AI and any other kind of startup. You have one kind of talk track, which is intimate, narrow, practical, tactical. It's about the customer's daily life and what problems they face. And then you have a broader, more visionary, more sweeping talk track for investors, for candidates, that's really around unique understanding, unique vision, its underlying characteristics of the market, which are creating a climate for your unique know-how. And that story about the scale and the insight becomes central. And then ultimately you start with an MVP, a complete bulletproof product for a small but immediately useful customer problem. Now, that's just a starting point, but it allows you to actually know that you're solving a real customer's problem because they actually gave you some money to solve it. And that helps you with investors. It helps you with your own understanding. It reinforces the confidence of the team and the morale of the organization. And it helps that customer and makes that customer a reference. So all of those virtuous cycles are keyed on that solution for an initial customer problem. So that's, if anything, my little formula. There are two views of what happens with AI over time. And I just share this to amuse you as much as anything. First, there is the radical, disruptive view of Scott Alexander and Daniel Kokotejo, who wrote maybe a science fiction story, maybe a projection of the future called AI 2027. It's kind of a future history of AI. Explaining how AI will expand exponentially in capability and impact in just the next 3 years, where the largest target for this AI models is AI research, and that you get this positive feedback loop, this bootstrapping that makes the models get better even faster than we've seen in the last 3 years, and that the combination of vastly increased model capacity and vast allocations of capital spending allows not only the models to get lots better, but then waves of byproduct advancements in science and medicines and robotics and manufacturing. And so that they actually plot out how many equivalent AI researchers come out of this, starting from, almost zero, where most of the AI researchers are in fact humans, to one that in the course of the next, now 2 years, we're talking about the equivalent of tens of millions of AI researchers, all pushing this forward. And the most science fiction-y part of it, the Skynet part of it, is the risk of existential threat in the misalignment of goals. That all of these AI models, as they go along, become more and more interested in furthering AI models and at the expense of human interests. And so this is the nightmare scenario of the computers deciding that humans are unnecessary to their goals. So a wild view. On the other hand, there's Arvind Narayanan and Sayash Kapoor, who sort of says, wait a minute. Yes, AI is exciting, AI is developing fast, but it is in most senses a normal technology that follows historical trajectories. We're currently in the period of invention, which leads to a period of initial application and finally broad adoption. And then the broad adoption of the technology diffuses into the economy and society and finally has a broad impact on human institutions. But that we are actually still very early in this process, and this process normally takes, with fundamentally new technologies, decades, so that this cycle, even in AI pace, is likely to be a decade or more to be fully diffused into society, in part because AI today has a significant capability reliability gap, meaning its peak capabilities are absolutely remarkable, but the uncertainty about whether it's going to produce that benefit under all circumstances, whether it's really reliable, is much higher. High uncertainty about its consistency and dependability. And the progress on intelligence metrics significantly overstates the real-world utility, and that humans will, in fact, must play a long-term role in monitoring, managing, and ensuring safety of the AI systems. And that will fundamentally gate the pace at which it gets deployed into all corners of the world. So it's a fairly conservative view versus a fairly radical view, but it's one that I think is worth examining both extremes and figure out where on this continuum you might live. So let me just finish with these takeaways. The AI models themselves, the fundamental potential for differentiation moves very fast. So you need to anchor your advantage, your edge, in something other than, oh, I'm using the latest model. Think about the workflow of your customer. Think about the context in which it's going to be used. Think about the data that you're using. I think that the models are dropping in price. They are commoditizing so fast that much more of the value shifts to integration and domain insight. You might want to be one of those model providers, but look at the way prices are dropping. They are in what very well may be a commodity product treadmill where it's actually hard to make money in the foundation models. Safety, security, explainability are requirements. They are constraints, but they're also design opportunities. They are things that represent additional problems that you can go solve for your customer. Your position in the stack defines your business model. You know, what do you make money on? Am I selling things by the token? Am I selling things by the hour, by the seat? Am I giving enterprise models? Am I selling outcomes? That's largely independent of whether you're doing something in real estate or doing something in IT services. And sustainable startups build trust loops. That is, they build trust with their customer. They build trustworthy products that actually do what the customers expect. They build trust in their data, and they build trust in how the data that they have is protected and used. And they build trust in public perception. Even non-users have opinions about AI and about the use of AI. And so all of these trust loops become really important to sustainability, just as trust loops apply in non-AI startups, in non-tech startups. So it's this mix of things that really we're driving on some things that are very different about AI, often about pace, often about sort of this reasoning capability, and some things which are commonly recurring issues like trust, which are not fundamentally different today than they were 100 years ago.